much noise from? Is there too much noise from my side because I don't have air conditioning? I'm running a fan.
No, I don't hear a thing.
Okay.
No, we're good.
It's yeah.
Very good. Thank you.
Okay. So welcome, everyone. We'll just take a few minutes before we start the program. So just wait for a few minutes before we start. Okay, good morning, good afternoon, and good evening, everyone. And welcome to session 7 of Data Science and Analytics Thought Leadership webinar. My name is Numan, and I'm with Industry X, and it's my great pleasure to introduce the topic for today, which is the tug of war between operational excellence and resilience. This is a topic which is of great interest for me, and we have our panelists are here who are going to be talking about this topic in detail. So let's do the introduction. We can start with Brett. Go ahead, Brett.
Sure, and Norman, thanks for the kickoff and thanks for having me again. My name is Brett Vermed, and I work at General Motors, and my role here at GM is I'm the director that's responsible for our big data infrastructure and platform engineering work that we do, which includes all of our big data, machine learning, AI/ML, and high performance compute infrastructure and software layers.
Welcome, Brett. Nabil, welcome to the program.
Thank you, Norman. Thank you for having me. Appreciate it. Hello, everyone. I'm Nabil, and I currently work for GM Financial, and I'm the VP of Data Science. And in that role, we basically focus on providing analytical solutions to the business that include machine learning, optimization, simulation. So it's a wide range of applications to basically make the organization as data-driven as possible. And I'm very glad to be here today.
Oh, no, our pleasure, Nabil. And our favorite, Dr. Chinam.
Hey, good morning, everyone. Good afternoon. Pleasure to be here today. Ratna Chinam, Professor and Chair for the Department of Industrial and Systems Engineering at Wayne State University. I have been in the space of data science and analytics for the past 30 years, starting with my dissertation research around using machine learning for advancing firm productivity in manufacturing and other functions. And so been active trying to advance research in this space, and I also assist small, medium, and large companies deploy analytics solutions. Very happy.
Good. Yeah, no, thank you. Thank you, Dr. Chinam. And this is our session 7. And if you want to find recordings of the previous sessions, you can go to industryx.org, and or you can visit our YouTube and Facebook channel to look at these recordings. I really want to thank our panelists for sticking around for this whole program and producing this wonderful program for everyone. So So just a few comments about Industry X. Industry X is a center of operational excellence at Wayne State University. Our agenda is to foster operational excellence, promote technology and AI in operational excellence and Industry 4.0. We work with companies on strategic to tactical to project basis, where we help companies on implementing data science or Industry 4.0 solutions in their organization. We also work with students, professionals, and at different levels. The four key areas for us, for Industry X, our four key pillars are number one is to promote thought leadership. Number two, to develop the solutions, advanced solutions connected to operational excellence. We're also providing workforce development solutions as well. So this is our agenda. This is what we do. So with this, I'm just going to start the program, this session, which is session 7. So data science, when it comes to data science, the first thing that comes to mind is we have a number of people who are looking into the data, they're mining data, and they are giving us some analysis of this data. And this is for, and this analysis is geared towards improving the organization. And this is like the common mindset that when I talk to people that I see, but there's more to it. And I want to start with Nabil first, that what do you mean by this short-term and long-term performance? How do you balance? What do you mean by this, Nabil?
Yeah, absolutely. I think that's really one of the toughest challenges that organizations face, and I don't think it gains enough attention and understanding. Basically, Noman, I think that if we are faced with a decision to address a problem, we tend to focus more on treating the symptom rather than solving the problem structurally. And so in the process, we tend to focus on getting quick results and declare that as a success without truly understanding the longer term impacts of what we're doing. And so we're action oriented by nature, and we prefer to do something. And to me, I call it the illusion of progress through any action, right? So I think there is a need to understand what is it that we are giving up by not addressing the problem structurally for the long term. And that relates to kind of how narrow or wide the scope of the problem is. I mean, as you can imagine, we tend to define problems in a way that we understand them, right? And this obviously has an impact on the scope. And so we define problems in such a way that it allows us to take action. I mean, how many times have you heard the expression, let's not boil the ocean? Well, let us understand the scope of the problem first, and then we can take action in a way that you can decompose the problem and attack it in pieces. But oftentimes we just focus on quick results because we need to satisfy Wall Street, we need to satisfy our managers, whatever the case may be. And that is a big challenge today in many organizations.
Well, Brett, I want to come to you about this word resilience. How do you see resilience in data science?
Noman, building on the points that Nabil made, right? And, businesses, industries, entire markets are actually very short-sighted in many ways, right? And are working toward business goals and objectives that are often measured in weeks and maybe months, and not in the long haul in terms of, quarters or years, even with the economic pressures that are constantly shifting and changing. I think, as we all are striving to use the data that we have available to us, striving to take advantage of emerging technologies and data science practices, those improvements tend to be and the objectives tend to be very short-term focused. And often we'll take a problem that and find a solution, find insights from the data using analytics and so forth, and then just kind of put it in the win column and move on to the next problem. I think the concept of resiliency is something that's emerging for me as an important consideration, because what might solve that problem today or in the near term may not be a valid solution in 6 months, a year, 2 years from now, as business circumstances change. So it's all about constantly evolving with changing business conditions to adapt, and not relying on what you might say as older models that were built on knowledge of the business conditions months and years ago, without constantly being introspective and evaluating their validity going forward, right? And that will then ensure that you get the benefits on an ongoing basis, and then start to fuel some of the, as you note in this chart, right, expansion and innovation can follow. But it's the tactical improvements that everybody is driven to day in, day out, and you have to take those wins and ensure that they're sustainable going forward.
Right. So when I look at maybe the progression or change for an organization, I see this 3 key phases. Phase 1 is improvement, and phase 2 is expansion of the business, and phase 3 is innovation. And in these 3 phases, a lot of the companies focus. First, they have to improve their bottom line or short-term their objectives, but at the same time, they need to keep an eye on the growth and the innovation, from the product innovation, process innovation, but more importantly these days, the business innovation as well. And what we see is the companies tend to focus predominantly on the improvement side, which is the short-term performance improvement, and they're not looking at the expansion or the growth and the innovation side. So I want to ask Dr. Chinam about his perspective of data science in this big picture, in this macro picture, that what is the role of data science and how organizations need to balance priorities in this big picture.
Great question, Nama. First of all, data science and analytics is just as relevant whether we are talking about operational issues, tactical issues such as, say, should I add more capacity at my warehouse? Do I need to, bring on board a subcontractor? Things of that sort, and the strategic problems as well. So data science and analytics is extremely important and can play an important role in allowing us to make better decisions in all these areas. Immediate operational needs, tactical and strategic. It's just that the nature of the analytics can be different. When we look at strategic problems, there is tremendous uncertainty. So the data science and analytics has to account for, for example, if we talk about electrification, mobility in the automotive industry, do we really understand how the markets will look like in 2030? Not really, right? So the importance of scenario planning and uncertainty and risk management, things like that takes more importance when we deal with strategic problems. But the reality is most firms today tend to focus on the short-term performance and not taking that strategic, perspective in trying to sort of manage the evolution of the firm. To summarize, data science analytics is absolutely important for all types of decisions, whether it be very strategic decisions such as should I go into market, a Brazilian market with my product or not, kinds of questions, just that the nature of the analytics would be different.
Got it. So Nabil, how do you see the role of data science in building resilience?
Well, I'm a big fan, Noman, of data science being very proactive, being a partner with the business. If we treat analytics as a service in the sense that, here's a problem, go solve it for me, or build me a model that will forecast sales or things of that nature, I think really we're missing the point. The best and most effective applications of data science I've seen come when data science is a partner with every function of the business, in the sense that the business will come and to data science say, here's the problem, or better yet, you have on an ongoing basis representation of data science in daily and weekly meetings that the business is conducting, so that the data science should live on a day-to-day basis with the business. And so that level of integration, that level of business understanding is key. But part of the problem is also analytics. Oftentimes I see large, even analytics departments not really take an interest in fully understanding the business at an operational level. And that really puts them at a disadvantage. And so in order for analytics to influence, they need to understand the business, and they need to really have a very strong business role. They need to put on this business hat if they want to influence. And we'll talk later about an example where a major initiative that led to some breakthroughs from a supply chain point of view was actually led by data science. The whole idea actually was generated by data science.
Right. So what you're describing here, Nabil, is a very typical change management scenario or change management challenge that we see. That when we have not only data science, but I've seen this with Lean, Six Sigma, or other programs where you have the silos where these improvement people are sitting on one side and operations people are sitting on the other side, and they're not talking to each other. So my question to Brett is that, do you see this concern at your level, Brett? And what are the things that you're doing in terms of improving this collaboration?
Yeah, and certainly that concern exists, right? And I think Nabil described it very well. It's the sweet spot between business acumen and technical acumen that really drives value, right? In a lot of cases, as you apply data science, and understanding both of those things and what tools to apply technically to a particular challenge is where it really becomes important. Sometimes what we've seen in our organization, and I've seen it elsewhere as well, you have to balance, and it comes back to some of what we talked about in an earlier webinar around org structure as well. You have this notion of a centralized team, right? And in that situation, you get perhaps better leverage of the technical talent, or you have a decentralized team in the various verticals or departments, however you think of them, who can then provide perhaps more specialized knowledge of the business. And I think really the way we're trying to attack that problem is to try to find a blend, right? And even in a centralized team, we tend to assign the data scientists and their key skill sets to areas of I'll say specialization. Not that they couldn't be leveraged in other areas, but you might have somebody who specializes in supply chain analytics. And certainly you could take that person and apply them to, a manufacturing capacity challenge, but their specialty area of expertise on the business side that complements their technical acumen would be in that supply chain area. So that tends to give you a little bit of the best of both worlds, and that helps address that challenge. I also think that it's really important that, to the point Nabil touched on, we'll talk about a use case later, that the data science team have some capacity to be innovative outside of assigned projects and assigned problem or challenge spaces, so that they can start to innovate and create solutions to problems and get out in front of the curve a little bit there and provide some value add that might not otherwise have manifested itself. So I think balancing that, what you say, project assignments with having some time reserved for innovative investigation and experimental work, as well as trying to balance the specialization and the centralization, because I've not talked to anybody in this industry that has enough data science expertise and doesn't want any more. And so you have to try to get the most out of them. And so you tend to leverage them across, but you have to be careful, because you do need that deep knowledge that Nabil has talked about to be able to bring a solution that makes sense at a business level to bear, right?
Right. No, it's a good point that maybe having that domain knowledge or having people working in certain work streams, I think that improves the output of data science.
Mm-hmm.
But Babu, that I want to ask you about this, the model resilience, that now we're talking about the changes that are coming, and the organization need to be resilient. They need to be working on different priorities, short-term and long-term. But in terms of the model building and keeping this model for maybe different users, what is your perspective on that, and how do you see that?
Sure, Dhamma. Great question. COVID has certainly revealed the critical importance of resilience of supply chains. We talked about this earlier, the struggles to just get the most basic of supplies. The semiconductor chip shortage that we're seeing today, Brett is going to be talking about, for example, what happened in the context of how, mobility patterns are changing because of COVID and so on and so forth. But I'll give you a slightly different example. So I'm currently assisting a firm that is in the business of helping retail firms better manage their operations around inventory management, around pricing, around marketing, things of that sort. So the technologies that they have built heavily rely upon benchmarking data. So for example, if I happen to be, delivering pizza, I want to basically see how the best franchisees that deliver pizza manage. How do they staff? How do they market? How do they, position themselves, and so on and so forth. So the platforms were working quite well until COVID happened. And because the core technology behind the platform relies on benchmarking data, and when you looked around, none of the retailers could sell any product. The inventory is accumulating. And the platform started telling all the retailers, all the franchisees, saying, carry more product, because everywhere you looked, everybody had product. It did not recognize that there is a major change point in the system. This is not representative of how, at this point in time, March 2020, at this time, this is the kind of a pattern that we should be seeing based on our understanding for seasonality and things of that sort. So that's a fantastic example of how the analytic models were not designed for resilience. They were not designed for anticipating change points in the market, right? That there is this disturbance, and how do you ensure that the recommendations still are reasonable? So that is an example of designing these analytic solutions for resilience. And of course, nobody can anticipate everything that's going to happen. For example, another example that we'll give you is Toyota now is beginning to slow its production. 10 years ago, when they had that tsunami, they recognized the importance of managing supply chain resilience and carrying enough safety stock, right? In the case of semiconductor chips, they know that it is a critical, component to build vehicles, and so they maintained very healthy safety stock to cope with these kind of disturbances. But nobody expected this kind of shortage to last, months and months and months, and now we are being told that this shortage might last years, right? And so they have taken, understood the importance of supply chain resilience, tried to carry the right kind of inventory, but the disturbance is still continuing, and they're now forced to basically cut down production and so forth. So all these kinds of things can be better managed if the analytics team thinks critically about how should I set up these models, what are the assumptions that I am making, how do I ensure that if the model is going to degrade, it's going to degrade gracefully and not completely fall apart and start making very bad recommendations.
Right. Excellent point. Another key point in terms of resilience or the overall effectiveness of these initiatives is the right performance indicators, key performance indicators. So when we set these indicators, that how we measure organizations or how we measure an output, that establishes a focus for that groups as well. I give you one example from my days in engineering and manufacturing. They both have different KPIs and how they get measured. And engineering KPIs are not designed many times to support manufacturing cost. Okay, so if a cost of the part can be high, but the overall cost, like the total life cycle cost, can be lower, the KPIs are designed as such that it inhibits certain groups to maybe invest more in the product cost. When we see this data science and how we are measuring data science, I want to maybe hear from Nabil about how are we measuring the output of data science, and how some of these KPIs can drive this behavior of short-term focus and long-term focus.
Yeah, I mean, it's this is a tough one because it's so fundamental, Noman, to how data science is perceived and to whether they get the funding that they need and the space that they need to innovate. And it depends on the culture, and this is where I think that data science have a role to play in influencing the culture of the business. Obviously, you see a lot of organization focus on hard KPIs, focusing on dollars, which is needed in a lot of cases. But the more you think about the longer term, the more you want to think about different types of KPIs that are perhaps not so financially driven for the short term, but more so focused on capabilities. So one of the key flaws today, I believe, in the misapplication of analytics is the whole concept of KPIs that focus on building capabilities for the long term. I mean, similar to what Brett and Dr. Chinnan mentioned, you have to have in place capabilities that help you make a turn, that help you pivot in the face of unexpected outcomes. And that means you need to have some inefficiency in the system. You need to have some excess resources, but that's not the mentality. And I always argue that organizations become brittle when they become too efficient, right? There's no friction in the system. They don't know how to behave if there is a different outcome. So I think I would call on really focusing on a special breed of KPIs that are capability related. And those capabilities should be in line with or grounded in scenario analysis, understanding what are the likely outcomes or what should we be prepared for. But again, sometimes efficiency wins and you end up doing great when times are good, but really falling off very quickly when there's any kind of a disruption.
That's good point. I think that's a big concern. So in terms of, I just want to maybe go back to Brett in terms of that, how GM, especially in the mobility area, how this data science is being used, and how the resilience is being thought about, or maybe the long-term objective of data science, Brett.
Sure. So, and specifically around vehicle telemetry data is probably I would say our most pervasive use case that demonstrates some of those concepts, Noman. You know, we've got 11 million vehicles on the road today in the United States that are transmitting back their telemetry data as they're being driven, and it's a very rich data set upon which a lot of analytics have been built. A lot of data science has been constructed to help with problems around a number of different dimensions like traffic pattern detection and shifts, electric vehicle charging patterns. We even look at how you can detect changes in road surfaces and construction zones based on traffic. There's just a whole litany of use cases that we use that data for. And pre-COVID, a lot of these analytics were built pre-COVID, and then nobody had, to the point Dr. Chinham had made earlier, you can't anticipate everything, right? And I would say it would be a very prophetic person that could have 2 years ago predicted that we're going to have the pandemic to the extent that we're all dealing with today. So one of the things that started to surface and it's a pattern I've seen more and more as analytics become more mainstream in critical business processes, and sometimes real-time analytics are in line in a business process that interacts with your customers and so forth. The shift in traffic patterns when everybody started working from home was monumental across the United States. And a lot of the models that had been built had to be reevaluated for accuracy and even applicability at all in light of those shifting traffic patterns. And without that, you could be led to some very incorrect conclusions, right? And maybe even incorrect or inappropriate interactions with your customer base potentially, right? And one of the things that was a lesson learned for me coming out of that whole experience is the fact that we talk about resiliency at the business level and how we can use data science to help businesses be more resilient and respond. This is clearly a case where in all these changing circumstances, whether it's, the silicon shortage and the supply chain implications and the production implications, the shifting in consumer preferences around, vehicle content, the availability of vehicles and pricing of vehicles, and what used car market will drive, prices escalating will drive people, to different decisions. All of those things are fundamentally based on assumptions that were really invalidated with the advent of the pandemic. So the business needs to be resilient, but also your models need to be resilient. And as you look at KPIs, there are business level KPIs that we were talking about, very critical, and making sure that they're aligned with the right objectives for the business, but what are the key KPIs that we look at that would be indicative of the performance of the models that we've built, right? And how do you detect those shifts and drifts that occur in results? Because one of the worst things that can happen is if you have critical analytics that are mainstream in a business decision process or mainstream in a customer interaction, and they start to drift and you don't detect those things, it can be very dangerous, right? It comes back to saying I learned from someone a long time ago that I like, data science is like a sharp scalpel, right? Handled by an expert, it can be very valuable and very useful, but mishandled, it can be a little bit dangerous and you can really hurt yourself if you're not careful, right? So I think of it on two levels. Number one is, the business resiliency that can be supported by analytics, and then the resiliency of the analytics themselves. And at least while you can't anticipate all of the unexpected changes, how would you design in some level of detection of drift that might be an indicator that your models are not providing the results or the accuracy that you had anticipated and trained them to? And I think both of those things, as data science practitioners, you need to be thinking about both levels.
Very good
Right.
comment. Very good comment, Brett. I mean, so often designing in resilience into the analytics model is a lot more challenging, but the ability to detect drifts, change points in the system is a lower hanging fruit. It's just that we need to think about it proactively, right? Otherwise you're not going to detect the change point. So are you putting in the effort to monitor, saying, is the model still producing meaningful results? Are the data streams giving me right data? Is the data, valid? How is it not valid? And at a minimum, alert the analytics team that, the model predictions are not consistent with, with the new reality and things of that sort. So yeah, I mean, what are we doing upfront to promote resilience? And again, making models adaptive and robust is a lot challenging task, but at a minimum, we should proactively plan for putting in place those monitoring, tasks to be able to detect some of these changes.
Yeah, and one of the things that comes to mind, and we've tried to use this in a couple of cases, there's a well-worn approach in manufacturing called failure modes effect analysis, if you're familiar with that. And it focuses on, I would say, proactive risk mitigation around the manufacturing process. Well, we try to apply that same thinking and really evaluate on three criteria. Number one, what would the severity of model drift in this case we're talking about? What would the severity of an undetected or a model inaccuracy that is trying to predict outcomes? So how severe would the impact be to your business? Secondly, how frequent is that, or how likely is that drift of going to occur? And the third thing is how detectable it is, because one of the worst things is even a minor, I would say minor severity outcome change that goes undetected over a long period of time can be substantial, right? So you have to think about them in terms of severity, frequency, and detectability. And so that's nothing new, right? That's a mindset that's been around in manufacturing for decades, but applying those same concepts in this particular context makes a lot of sense to me. And we've tried to look at our practices around data science in that, from that lens, and it might help bring perspective as you start to build that in. Where do you focus your energies? Because you can't mitigate every possible negative outcome, right?
This is a good point. I was not paying attention to this FMEA point. I think that you brought up a good point. I think I think is very important, I think, to do this type of analysis. Another point that I want to bring up here is the quality of dialogue that goes within the team, within the management, within the leadership around this. Because at the end of the day, and there's a lot of research on this, that in terms of decision making, that especially in certain decision making, like strategic decision making, the quality of the dialogue brings more value than the quality of the data. So how do we balance the dialogue and the data in terms of the decision making? I think that need to be incorporated into the decision making process to manage that if all the decisions are made solely on data. I think that we need to take a look at how we can bring dialogue and maybe the team input in that as well.
Yeah, Norman, I think that is really a great point. That's not, I believe, emphasized enough. You can argue that same point that you're making should be strong in terms of collaboration within data science, and it should be across different functions, between data science and marketing, data science, finance, strategy, etc. And, I mean, Dr. Chinam knows this. This is one area that I feel there's a lot of opportunity, and some of the work that I've done in that space really gives some good examples of how you can use analytics to help understand the level of collaboration within an organization, right? And the argument here is that any resilient system, or for a system to be resilient, you need participation, you need dialogue, you need those connections, right? And one example that I can provide is, we had at some point an analytics organization where you had people in the US and people in Asia, and we implemented network analysis to help them understand how well they're collaborating across the ocean, if you will. And that's an example of actually applying analytics to improve analytics, because we tend to think about applying analytics only on the business side, but I think there's an opportunity to implement analytics for self-discovery within data science to make data science itself more resilient and more adaptable, right? I mean, to Brett's point, how do we discover these shifts and drifts? Yeah, you can have automated pipelines, but at the end of the day, it's all about people understanding them and making decisions and collaborating. And oftentimes that expertise is scattered across the globe and needed a way to make it highly connected.
Yeah, and that's a great point, right? And it really comes back to the very iterative nature of the data science lifecycle. For any model, any solution, it's all about the iteration. At best, in my view, you can get signals that may indicate that there's some drift and shift that has occurred, and more focus on the model outcomes might be necessary and may require reevaluation of how the model's been constructed or the quality of the data that's being used and so forth. But it's that iterative nature and the communication in the business context and what's changed that requires that partnership and that conversation almost 100% of the time.
I agree. So, Brett, you mentioned earlier in the conversation about this domain knowledge and how the pairing of data scientists with a certain domain can really help the output of the models and the decision making. I want to come to Nabil about this particular point about, especially in supply chain, and you've been working in the industry for a long time, how this approach has worked in having better decision making in supply chain.
Sure. I mean, this is an interesting example where we were able to dramatically improve the understanding of the supply chain the risks that are involved, understanding the dynamics, if you will, of that supply chain. I mean, unfortunately, if you, and this came about based on a series of incidents, right? You had the tsunami in Japan, you had floods and typhoons in Thailand and in other places. So we have a lot of examples that really suggest that your supply chain is vulnerable. And what's interesting about this example is that that whole initiative was led by data science. So data science actually proposed the idea, they led the implementation, and they worked very closely with the business. But the prerequisites were that data science had credibility. So going back to our previous discussions, if you don't understand the business, you don't play. If you don't speak the language of the business, you don't play. I mean, how often have we seen data scientists give business presentations that's kind of filled with equations because it's making them feel good, but then the business owners or the stakeholders, they're just like, they tune out. The other item here is that in this particular context, we've made very clear decisions about how to position data science, right? Where do we want to play? And so you can say, well, data science can be sustaining in the sense that you can apply solutions to preserve the status quo, make processes more efficient and effective, or you can make it transformative. And this is where data science solutions change the way things are done. So you've got those two extremes, and then you've got another decision point, which is, are you exploring in the sense that are you just playing around the edges and experimenting, or are you exploiting in the sense that you're trying to take a domain and make it as data-driven as possible? So in this case, we connected with a major insurance company, and we've looked at their own risk assessment capabilities. I mean, they have data on flood zones, they have data on shipping containers, the various products that are in those containers, the delays in different ports. Very valuable data that basically wasn't used before. And so we collaborated with them to build a network that is global, that has those inherent risk points within it. And then you run simulations to understand where you have these weaknesses in the system. And so that collaboration with this major insurance company led to major changes in the selection of suppliers and how we even design products, because you're taking the supply chain into consideration. But again, the key point here is that this effort was initiated by data science, and to me, that's a great example of what data science can do once it's credible, once it has the ears of the business.
Excellent point, because that's where I think if we have this type of empowerment and the leadership that is coming out of data science, I think that's where the real transformation, more transformative stories like this can happen as well. Brett, Alan Amici is on the line, and he was talking about this GM example, and I want to ask you to make a comment on that. It's in the chat if you can see that.
Mm-hmm. Yeah, absolutely. I did see it in the chat. Now it's a really great point, right? One of the things that you have to be guarded against, in my view, is the notion that you can develop a model that can detect and respond to every possible variation or outcome. And the concept of a self-healing model is something that is interesting conceptually, very much so, but it tends to, as you well pointed out, right, is dramatically, exponentially increase the complexity of building a model. That in turn can perhaps reduce reliability issues with the predicted outcomes. It can increase the cost of developing that model. It can really increase the cost of maintaining that model. And imagine that the team that builds a model like that moves on to another assignment and is no longer available. And then the poor guy who comes around as the next data scientist to enhance the model is dealing with that level of complexity. I think, it's probably more prudent to be able to detect when the model appears to drift from the expected results and expected outcomes, and then get back into the iterative life cycle and let the data scientists and the business and their business partners look at the entire context. Has something in the business environment shifted, like the pandemic introduced massive changes in the traffic patterns, for example, with the example we've cited, right? Or has something about the data quality drifted that has introduced some uncertainty into the model outcomes? And then let the team respond with a bigger context. Certainly there are some, I would say, more minor things that a model could be built to respond to in a self-healing way, but my view is be guarded against it, because you detract from the main business purpose of building the model in the first place and spend more energy around trying to error-proof it than, the likelihood of you detecting every possible change that's going to occur is low anyway, right? So that's why you need the expertise, the business and technical expertise on the team to respond to it. But it really is important to get those, as you call them, flags raised, so that you can have a look, because you can put that model to work and then move on to the next and the next problem. And if you're not thinking about it, suddenly you have that sharp scalpel come out and you kind of cut yourself with it, right?
Right, agree. So Nabil, as we're coming towards the end of this program, culture is very important. What are your thoughts on the culture, developing this culture of resilience in an organization?
Yeah, I mean, obviously that's in a way what's going to move the needle, right? I mean, you can bring in the best technology, you can improve processes. If the culture isn't adaptive, then not much is going to happen. And this is where I say that the data science and analytics, we have a responsibility to influence that culture. We cannot just take a back seat and say, you know what, there's not a whole lot that we can do. That should be part of our goal, is to influence the culture. And we have to do it in smart ways. But I think, to me, it's in particular when we have disruptions, those are opportunities, because that's where we can say, you know what, experience and judgment about how to deal with this situation isn't necessarily readily available based on what you've experienced in the past. And this is where you need the power of data, you need the power of analytics, simulation, to basically build the case. So my advice is that we need to watch for these opportunities to demonstrate that value. And I think the times we're living in right now is a great opportunity, unfortunately, in the midst of all these tragedies, to demonstrate what data science can do and how it can help both the level of understanding and then influence a greater level of preparation for the future.
Right. I think I believe that within the data science organization and the overall organization, the predominant culture or the practices or shared beliefs that the organization has for a long time, that prevails. So if an organization is maybe a compliance organization and we see that a lot of the organizations, especially automotive, has become compliance organizations because of safety rules, or maybe the how we have done business for a long time, and we have maybe promoted to be less innovative, not to take too many risks, not to go out and do something which is maybe not valuable for the company. And all the things that we're talking about here focus more on the efficiency, always think about cost, okay? And when you have those type of values or the beliefs in the organization, the data science organization is gonna follow the same suit. So in my view, we need to think, first we need to understand the organization, culture, beliefs, their behaviors, and then understand that where we are heading, and think about the two different step two, expansion and innovation, and design a culture, a new culture, which is maybe failure is permitted, lessons learned is a good outcome of an activity. And once we start to promote that, empower people, and I think we're going to see a lot more activity and a lot more people open up.
Very well put, Norman. Very well. Can't agree anymore, right? I mean, yeah, very well said.
So with this, maybe just key takeaways. We're coming to an end. We have a few more minutes. So let me start with Dr. Chinam. Dr. Chinam, key takeaways from this webinar or this topic.
So two things. Resilience is extremely important, and we learned that the hard way through COVID and other recent events. And data science and analytics has a role to play for both business resilience, and also data scientists have to think about the resilience of their products. Very, very important.
Got it. Brett?
I think, Norman, the one key thing is probably keyed around the second bullet, right? A model that you've built is really never complete, right? There's nothing static about business these days. It doesn't matter what industry we're operating in. It doesn't matter what department or function you operate in. Things are constantly changing. In fact, the rate of change in business now is accelerating to a point that we've never seen before in the auto industry. More change in the next 5 than the last 50 is very common, a common perspective. So as you think about the role of data science and the resiliency of the business, as well as the resiliency of the models that get produced and the assets that the data scientists construct, you need to think about how it's a continuous life cycle, right? And you have to think in terms of detectability of drift. That's a big point for me when I think about resilience. We have a lot of KPIs that detect drift of business results. We don't have as much around detection of model results and outcomes, and that's probably a continuous improvement and a maturation that the industry needs to go through. But really focusing on the fact that there is a continuous life cycle that needs to be built as you manage the role of data science and business resiliency.
Got it. No, thank you. Brett, Nabil?
Yeah, so just very quickly to wrap it up, building on both Dr. Chinam and Brett's thoughts. At the end of the day, today we tend to measure what's easy to measure. We tend to measure something because we have available data. And I think one of the key challenges right now is to take resilience from a concept to something that is operational. And I think analytics and data science can play a role in making resilience more of a measured or measurable concept, with the right KPIs. So I think that's, to me, the kind of the next frontier is, how do you operationalize resilience, and what is the role of analytics in making that happen?
Got it. No, excellent points. So with this, I want to thank the panelists, and our next webinar is going to be the last webinar of this series, and it's going to talk about the data governance. And both Brett and Nabil have years of experience in this field, so we'd love to hear from them, and also we'd love to hear Dr. Chittum's perspective on this. So September 30th, last Thursday of each month, join us in this session 8 and the last session. And with this, I close the webinar. I thank everyone who joined this this program, and all the people who are going to be listening to this in the future. So I thank everyone, and with this, I thank everyone and say goodbye. Thank you.
Thank you,
Thank you,
Norman.
everyone.
Thank you all. Yeah.
Thanks, everyone.